The lecture I am giving today is laying down air quality monitoring network. Without the assessments of air quality monitoring, we cannot go for any planning on air quality management in a place. This is very important. So it is very important to design air quality monitoring network. And this is my deliver to you on laying down air quality monitoring network. So the next one is concept of monitoring. What is actually the monitoring? The generic nature of three words, survey, surveillance, and monitoring, which I am trying to explain you. These are very close words, survey, surveillance, and monitoring. Survey is actually a finite duration intensive program to measure the quality of environment component. That means with a time-bound program where we have to measure the quality of environment, particularly here is the air quality environment, air quality component for a specific purpose to say the assays of the pollution like that. Surveillance is a continuous specific measurement and observation for the purpose of environment quality management and operational activities. Whereas monitoring is the long-term standardized measurement and observation of environment component in order to define status and trends. So monitoring is actually going for the trend of the air quality for a long time. It's a long time program where survey is an intensive program with a finite duration. Surveillance is a continuous specific measurement and observation for the purpose of environmental quality management and operational activity. Surveillance for a particular period, for a particular parameter, for a particular observation to see that how it is changing. So next steps, we are classification of monitoring then. One is the intensive monitoring, where is the extensive monitoring. Intensive monitoring, time-bound, finite monitoring, that is survey, and surveillance, as I told already, continuous time-bound program. Where extensive programs is to assess the trends and status long-term program. So next time, we are saying that what is actually monitoring is doing. Monitoring program actually capture the variations. So if you set an observation or experiment, it generates data, and data when you process, you give the information. From the information, we are coming to the conclusion, either the inferences of the experiments, or we can predict the phenomena for the future. If it is a repetitive, data is repetitive, and then we have a low variation. That means its data is precise with a very low range. It is a low variation and it attains the certainty. Whereas in the case of spread, if data has a long spread, big range, then that is a high variation and it is an uncertainty, and that going for a random fluctuation. So if it is a repetitive, it is a precise with a small range which attains a certainty, where you have a long range and high variation which gives you the uncertainty or random fluctuations. So variation of the three types, to tell you very frankly, One is a spatial variation. That means where the area have a space, and temporal, that is with the time, and there is a random variation. It happens that suddenly the storm came which carries the your particulate and gives a high fluctuating data. It's a random type of things. The spatial variation either be longitudinal, that means area length, and lateral is the spread, and vertical, that is pairs, that is different layers upwards, which is happening in the air pollution particularly. And because the particle spreading is done because of mixing zone, which I have already explained to you in the meteorology. And the temporal variation, it is day-to-day variations, monthly variations. These are the temporal variations. Diurnal, within a day, there is a variation. It happens when the inversion takes place. There is a diurnal variation is taken. Seasonal variation is very predominant in India because in summer the pollution is very less actually is observed, whereas in the case of winter it is intense. And in the case of winter also, within a day there is also intense morning, very high air pollution, and daytime it's a lower, and in the afternoon and night it again comes to very high pollutions. And it's a, if the trend you are taking, we also taking year to year, that is a long-term variation, random, which I've already explained to you. So this is the nature of the variation which has to be captured within the monitoring program. Next, there are temporal variation is there. That is, I am saying is that is a seasonal pattern. That is, I have told already that there is a seasonal variation is there. So it is going up, and then if it is coming down, there's a rain is there, or there is a kind of a good dispersion is taking place. That time also the variation observed is low. And with the season, when the winter comes, where the dispersibility is very low, that is called that is the position of the temporal seasonal variations. Where is time, that means trend with is small, that year to year with a seasonal variation. If that trend is captured for a long time, say 10 years data, then this kind of data is it's called a trend with a seasonal variations, year to year variation, as well as the seasonal variation. This is the variation which we have captured in the monitoring program. Monitoring then is a systematic observation in order to clear the inferences, that is the prediction, about an experiment or phenomena for which it is designed. Systematic observations refers periodic observation with regular interval. It has three components: where to monitor, where to take the sample, that is the location of the sampling point, what to measure, what the parameter has to be defined, and when, how often this, that is a frequency, how often we have to measure the things, that is the frequency of the observation. If there is a high fluctuation, then the frequency will be more, that is tending towards a continuous monitoring. Where the fluctuation is low, we may not go for a continuous monitoring. We may go for a manual monitoring to make it more cost effective. Next. So we have to now understand how to select the site of the, that means the location of the monitoring program. You have to find out what is your air quality objective. If it is if you want to go for an objective, if you want to capture that the objective is that we have to capture intense system, intense monitoring, intense air pollution where dispersibility flow, or we have taken gate trend analysis. Accordingly, the site selection will be fixed. There are site category, site selection, site location criteria, physical requirement, and planning a monitoring network. These are the topics has to be dealt in the following observations. Next. Sites located determine the highest concentration. That means expected pollutant occurs in the area covered by the network. That was the things. That means maximum ground level concentration to be captured. Site located to measure typical concentration areas of high population density. Site located to determine the impact of significant sources of the and site located to determine general background concentration level. Site located to determine the extent of regional pollutant transport. It is also to be interesting point that in a place, in a city, maybe city has its own pollution, but it is added because of the transport, because of the air movement. The transport is from the other places is also coming. That is the regional pollutant transport. That also has to be, if you want to capture, your sites will be located accordingly. Sites located to measure air pollution impacts on visibility, vegetation damage, or other welfare-based impacts. It is also important that what is the, particularly in India, it has happened that there is a question of the visibility is lost because the storm of the air, storm of the dust storm is taking place. Is also visibility has been killed. There is an industry which also creates a high amount of sudden release of the high amount of air pollutants, particulate, vegetation damage. This is happened due to sulfur dioxide emission or the particulate emission or any other ozone impact also or other welfare based mechanisms that is the health of the people. That was the things. This is the types of air quality monitoring sites in a nutshell I have explained to you. There are three types of sites. One is the urban including traffic, residential and commercial places. Suburbans, traffic and industrial, and rural sites, the background areas. Even if you want to assess the urban air pollution measurement program, the microenvironment selected and often classified. This is the classification: urban, suburban, and rural site. Rural site is giving the background so you can compare what is happening in the urban and suburban areas. Next. Logistics. It is a very, very important thing. Past and current monitoring results. You have to, if you want to select, you have to see that whether past or current monitoring results are available. Maybe done by other agencies, but we can take these things. Then site accessibility. Site should be accessible all the time, 24/7. If you are going for a selection of a sites where your accessibility is lost, that means you cannot enter in the night time or in the holidays, then you are losing some kind of a, if there is something wrong in the instrumentation, you cannot rectify very fast. Power accessibility, that means uninterrupted power should be available in the site selection. Topographical effects, that means if you are selecting a site which has been covered by a vegetation, so that you are not capturing the actual air pollution because it has been prevented by the vegetation cover, or a building site which also can create this kind of a prevention of actual representative samples. Local interferences, that is this. This is happening because of the, I have a very bad experience with this once. We have installed the things with monitoring stations in a university area, and there is some kind of a problems in university boys, and that creates, that stops the local interferences of the things. And the third last point is the security. It should not be stolen. The instrument should not be stolen. It has happened in the background station. It has happened. Rural people may not aware of this, what purpose this instrument is there. They may hamper the instruments. They may take sometimes the parts of the instrument. That is the security hazard is there. Next, let us go for the next slide. That is in general, the following conditions should be met. The site should be away from major pollution sources. Why we are telling these things? If you are very near to a major polluting sources, say thermal power stations, or for a industry, then it will capture only the impact of that industry or thermal power station. So there should be at least 25 meters away from domestic chimney, especially if the chimneys are lower than the sampling point. With the larger source, the distance should be greater. That means a bigger source is there, the power station, the distance should be greater. Even near to a DG set, we should not have a monitoring sites. So that site should be away from a major polluting source. Only with then it will not give the ambient air quality, but it will capture the impact of that sources. The site should be away from absorbing surfaces such as building material. That means the clearance to be allowed will depend on the absorbing properties of the thermal material for the pollutant in question. But it will normally be at least in 1 meter away from the absorbing material. The objective of monitoring often to measure trends in air quality, and measurements are to be conducted over a long time. That I have already told you, that the site should be selected such that it is expected to remain a representative site over a long time and no land use changes. That means we will go for an urban system where the land use should not be automatically changes. That means it is a complete land use, physical planning has been over, the construction is over, and no change is required in the near vicinity. Then you will select that place as a long-term trend analysis site. The instrument must be located in such a place where the free flow of air is available. One of the conditions on the ambient air quality monitoring stations, that it should have a free flow of the air. That means air should not be restricted by a building or by a monument or by a stadium, such that should not be there. That already I have told it, that it is the free flow of air is available. Next, physical dash. I have told you it has to be it should be available for a long period of time. Generally, we prefer to have a near to a government building and or a police building, or we are seeing that where the security is available and easy access is available anytime throughout the world. Electricity, water, telephone connection should be available. It should be vandal proof. That means I have told you that it is to be vandal proof, that there should not be any extraordinary situation which cannot vandalize the whole things, and protected from extreme weather. That means if it is a extreme weather means huge rainfall, etc. is there, it should be protected from that places. Next. What additional background information is needed? Of course, air The vehicle of air pollution pollutants is the condition of the meteorology. That is means the wind speed, wind direction, then mixing height, which I have already explained to you in the case of meteorology. Then the second question is the topography. That already I have told you there should not be any prevention of free flow of the air due to the big vegetation cover or a building and the population density. It is always see that how the air pollutants moves. What is their impact? If we impact that the station should measure the impact of the health, then where the maximum population is there, there should be at least one station to capture that what is the air ground level concentration of the air pollutants of that area where the huge population is at the risk. Emission sources and the rates, that means what are the emissions, inventory of the emission sources must be there. Without the inventory of the emission sources, without the meteorological condition, and also the habitat, all the heritage buildings are there. All the things should be considered when planning a monitoring network. Next. So meteorological condition, wind speed and wind direction. This is given by the wind rows. And mixing height will tell the maximum GLC. That means ground level concentration. It's a big source is there. Where is the place the air quality monitoring station should be located to capture the ground level concentration, maximum ground level concentration. And wind speed and wind rows, wind direction, that is the wind rows, that is given here. That in which the pollutant is transported on what direction, on what speed. Next. Now, locating stations to monitor the impact of a source. C. Movement of the air and local meteorology and topography such as hillocks should be considered. Now, movement of the air is direction by the arrow. And we have a stations, upwind station, that is the one station, that is the background station. If direction of the wind is from there, from on point 1, so 1 should be a background station. And there is a source, that is a rate, big colored is a source, and the maximum GLC is expected 3, station 3. So there should be one monitoring station is there. And 2 and 3 are the two station considered as number 2. These 2 stations are the stations which are affected, and 4, that is a crossword stations, that is at least one crossword station is recommended. I prefer that there should be a 2 crossword station. If there is a fluctuation of the air, so 2 crossword station will be there. So this should be a minimum location of the monitoring stations to capture the impact of a source which has been given with the red circle, deep red circle in this network design. Next. Now, if we go the monitoring network of these things, that is more defined. There are some kind central business district is there. There are some kind of a air pollution activities there. So and there are station, the air is moving in different direction. You have seen these things here because the arrow is coming from different direction. In that case, the upwind and background direction is definitely the one. 2 is the station in affected areas where the impact of the central business area is there. And 3 is the maximum GLC. Observe, there are 2 stations signaling at number 2, because the direction of the wind is changing. As a result, the 2 stations are considered as number 2 two station is considered in two places. And there is the 3, that is maximum GLC expected. And 4 is this, where the extreme downwind could show decay of GLC. That means where the air impact of the air pollution is low in compared to 3. So this is a observed meteorology to assess the impact of the sources. Next. Now we are going for a grid where the wind direction, wind speed may be changing, and there is a big urban area is there. So in that case, we have these stations there, but there are small blue points are there where we can go for a small station. Maybe number 2, 3, and 4 is a real time situation. That means continuous monitoring we are taking place in that area, because that is the area where the maximum effect is expected. But this where the other points are there, small pools, we can go for either a manual monitoring or sensor based cost effective monitoring, so they get the background information other places of the grid where the meteorological fluctuations can be captured. Next. I have already told what we are doing. We are taking to representative sample. The station must be a representative one. It is comparability is there, long-term availability to ascertain trends, land use in the vicinity are likely to change. That means it is very important. If the land use change, the character of the station will be changed. So generally, in old cities, the land use is definitely not changing. But in new urban areas where the land use is also changing, if land use is not unlikely to change, the station will give a representative observation for a long time. Next. Selection of parameters. Generally, we are doing a primary criteria, that is the sulfur dioxide, nitrogen oxides, PM10 and PM2.5. In case of where the traffic is maximum, the carbon monoxide and volatile organic compounds are also given. Sometimes in India, the volatile organic compounds has been go for a particular emission. That is, if the traffic is too much, so measurement of benzene is given straight away, rather than do too much general VOC. We should go straight away to benzene. There is a significant regional contribution to the problem. More emphasis will be on the monitoring ozone and particulate matter, if there is significant regional contribution is there. Large-scale phenomena such as winter smoke episodes or summer dust cloud, local impact should be avoided. That means local impact should be about a large-scale phenomena, that is winter smoke episodes or summer dust cloud. We also capture, but it should be a random fluctuation for a few days episodes. Next. The question is that how many stations we should do. That is generally 100,000, less than 100,000 population. We are doing number 4 stations. 4 stations we are, minimum 4 stations is there. If it is a 100,000, less than 100,000 population. In India, 100,000 population is called a class 1 city. So more than 50,000 and less than 100,000 is a class 1 city. 100,000 to 1 million, it is a 4 plus 0.6. That is the per 100,000 population. That is the way we are calculating. If it is a 5 million, 1 million to 5 million cities are mega cities we have it. Then it is a 7.5 to 0.25, and more than 5 million population are there, then we go for a 12 station. Generally, I tell you very frankly, because of the cost effectiveness, the class 1 city, that is the less than 100,000 population, we go for a 3. More than 1 million stations, more than 1 million population, we go for a 9 stations. And those with the industrial city, we go for a 6 stations. And those cities which are capital of our states, as India has a lot of states are there, state capital, which are not a metropolitan city, that means less than 1 million population, but more than 1 million population, we go for a 6 station. Sulfur dioxide with the same phenomena we are giving, sulfur dioxide and a nitrogen dioxide. And carbon monoxide, we generally go for a higher traffic crossings, because where the maximum capture of the carbon monoxide is offered. So these are the number of stations in a nutshell. It's a very thumb rule, but it is better. Now we have find that instead of going for a thumb rule, it is better to design a grid. In the grid, maximum GLC, as observed earlier, maximum GLC and maximum impact station should be real-time continuous monitoring stations, and which with the sophisticated instruments, which is a bit costly but giving a very reliable results. And other part of the grid may be manual stations or sensor-based. Very good sensor-based monitoring systems are coming nowadays. We can encourage and see that certified sensor-based monitoring equipments are installed in that places. Next. Now we are going for a standards. There are a lot of debates in the standards are there. In European country, there is one set of standards. In the US EPA also have a lot of standards. And in India, we are doing the standards considering our huge past data. These are recent standards we have been laid down. We have been doing this air quality monitoring since 1982, actually 82, 83, mid of 80s, better to say, mid of 80s and today. So there are long-term background results are there. There are a lot of research and the research organization and the universities also laying down a lot of monitoring for their research. All the past data we considered. So we have a two type of place, whether industrial, residential, rural and other areas. And what is that ecologically sensitive area notified by the central government. Central government has notified some ecologically sensitive area, and that is the two places different type of standard is given. So sulfur dioxide, we have an annual and 24 hours. Nitrogen dioxide also, we have a annual and 24 hours. And we have a little difference between this industrial and the ecologically sensitive. There are some differences are there. Particulate matter, we have a average, annual average. Annual average means at least 106 observations should be there. That is at least 106 observations we should capture. And that means 106 days observation we should consider for the annual average. So in case of the ozone, it's 8 hours and 1 hour. And in case of the lead, it is a average and a 24 hours. Now the question is that we have given that parameters also changing, mu g per normal meter cube, and in case of the all the thing is a mu g per normal, the microgram per normal meter cube. This is our unit. Next. And the carbon monoxide, we have a 8 hours and 1 hours, because carbon monoxide is 1 hour's extreme condition is a fatal. That's why we have given 1 hour. Whereas ammonia, benzene we are going for the annual average, and the cases of the arsenic, these are all annual average. In the case of nickel, arsenic, and benzopyrene, it is also coming the annual average. So right side, there is giving the methods of measurement. That means this, if the air quality monitoring follows these methods of measurement, it is illegal. That means the results are coming legal, and people can use, regulatory authority can use these results for legal purposes. Lot of public interest litigations is there in the court, and these are all coming if the data has been collected on the methods of the measurement given the right side. So this is in a nutshell our air quality monitoring network. Every country is advised to develop their own standards, considering their socio-economic condition, considering their rate of industrialization and urbanization, and exposure of the urban people. So all things should be considered when you develop your own air quality standard. You can take the help of the Indian, European, or American, or any other agencies, but better, always taking the help of this good, but better you go for a kind of a very pragmatic approach. Otherwise, you have a very good objective, very good trend, but you can never make these things. So it is better, step by step, it is taking action. So for 10 years, and every 10 years, you review the ambient air quality monitor and ambient air quality standard. Next. Now we are going for a monitoring program. Assess the trend and status, locating station for baseline impact of sources. Parameters is sulfur dioxide, NOx, particulate matter. Particulate matter means PM10 and PM2.5, and carbon monoxide. And instrument will be manual and real time. Participatory body is a regulatory body, regulatory organization. Critical areas, survey for a selection of monitoring grid, critical parameters, sensor-based smart and affordable system. Regulatory body and academic institute can also go in. And surveillance program. That means in the case of some time, say winter time, India, some cities in northern India and Indo-Gangetic valleys actually, there you will find that grid system is there. That should be done for different cities. Real-time and monitoring for critical parameters, sensor-based. May not be all the parameters you have to take, critical parameter. If it is a particulate matter problem, you take the particulate matter problem. It's a carbon monoxide problem, you take the carbon monoxide problem. And that is, instrument action is sensor-based plus real-time in critical location, regulatory body plus academic institute plus citizens' participations. This is now we are encouraging that there should be a citizen participation. And citizen participation should be guided by the regulatory authority so that more data is available for the decision making process. Ambient air quality monitoring programs should be designed in such a manner the science-based decision making process can be taken by the regulatory authority and the government, concerned government. So this is our monitoring program. Thank you very much. If you have, because the interaction is not there, so if you have any questions, you may write to CAC. We will try our best to answer the same. Thank you again. Thank you.